Okay, now we're looking at the hormonal control of blood pressure. The hormonal control of blood pressure. Okay. Our interest in this hormonal control of blood pressure, go here, I'll put that up. Our interest in the hormonal control of blood pressure is going to be the renin-angiotensin system, aldosterone, ADH, epinephrine, and adrenal natriuretic. Now recall in the last one we were doing the nervous. Right here I mentioned that alpha receptors do vasoconstriction, that the blood vessels have alpha receptors, okay? And we'll say this again for epinephrine and norepinephrine, right? But right now we're into hormonal, and I'm going to go over here and pull it there for hormonal. So, okay. So this renin-angio, okay. All right. So under hormonal, we have the renin-angiotensin system, aldosterone, ADH, epinephrine, and something called adrenal natriuretic factor. All right, let's talk on this. Let's talk on the renin-angiotensin system, which is really one of the more powerful systems hormonally for blood pressure control. Powerful systems for blood pressure control. Okay, let's go through it now. Angiotensinogen, whenever you see the term ogen, that means precursor, not working. Angiotensinogen is produced by the liver. It's secreted into the circulation. So it's produced by an intact liver. It's one of our plasma proteins. Okay? So we have a circulating concentration in the blood of angiotensinogen. But again, this is precursor. It does nothing. There's a hormone type enzyme produced and secreted by the kidney known as renin. And what renin does is to convert angiotensinogen to angiotensin Roman numeral 1. Now I'm going to write here, this does nothing. This substance does nothing. Okay, you see me writing that. It's an intermediary. It's an intermediary. What will happen is that endothelial cells, go back to earlier, in several locations, particularly the lungs, produce and secrete angiotensin converting enzyme. Let's look at that. Angiotensin converting enzyme. Angiotensin converting enzyme. Angiotensin converting enzyme will convert angiotensin 1 to angiotensin 2. Angiotensin 2 has a lot of good functions. Okay? All right. We go here now. Angiotensin 2 has several functions. Some are act as a powerful vasoconstrictor. Now, if it acts as a powerful vasoconstrictor, that means it would increase blood pressure, because remember, vasoconstriction will increase systemic vascular resistance. Okay, so powerful vasoconstrictor. It also can stimulate production of aldosterone, we'll talk about, from the adrenal cortex. And it can also stimulate the production of ADH, antidiuretic hormone, from the posterior pituitary, we'll talk about. So angiotensin 2 is the key thing. Let's look here. So I'm saying that angiotensin 2, so we have angiotensinogen, renin from the kidney would cause it to go to angiotensin 1. Angiotensin converting enzyme would take it to 2. When it takes it to 2, it can cause cardiac action. Okay. It can also increase systemic vasoconstriction, we mentioned. It can increase blood volume, and that's going to occur primarily via ADH, antidiuretic hormone. And then it can hold on to sodium, which is primarily going to be aldosterone. And if you hold sodium, you're going to hold water. See? All right. Now, I want to bring up the fact here. Okay. The we said angiotensinogen converts to angiotensin 1 because of a hormone renin produced by the kidney. All right. Now, this is the rate limiting step. Let me explain this. Angiotensinogen is produced at the same level all the time. It's really called a constitutive secretion. A constitutive secretion. Okay? This right here is produced all the time. Constitutive. But this one some will call a facultative secretion or modifying secretion because the amount of renin can go up and down depending on what blood pressure the kidney sees. So the amount of angiotensin II depends on the amount of renin. Renin's the rate limiting. Here's the kidney. In the kidney, renin is produced. How much renin is being produced is what blood pressure the kidney sees. What blood pressure the kidney sees. Now, the kidney should get a good sampling of the normal blood pressure in the body. But let's take this assumption. One reason for high blood pressure, kidney problem. Let me show you something. If the renal artery, now see, this is where we got, remember we had collateral circulation and an end artery. Collateral circulation meant you have several arteries going to the same, end artery only one. Unfortunately, your kidneys have only one, their end artery. The kidney can only interpret what this artery brings it. So if you had some constriction of this artery, let's say you had atherosclerosis, or a fancier term, renal artery stenosis. Remember we talked about stenosis in heart, narrowing. Renal artery stenosis, then the kidney would see a lower blood pressure than the rest of the body. If this had renal artery stenosis, the kidney would see a lower blood pressure. The kidney then would increase its production of renin. When it increased its production of renin, it would make more angiotensin II ultimately, and your blood pressure would go up abnormally. Because let's say you already had a normal blood pressure, but the kidney wasn't seeing that. Just to show you something. All right, going a little further. Right here, this is your adrenal gland that sits at the top of the kidney. This is your adrenal gland. The adrenal gland has two parts to it. The middle is called the adrenal medulla. The adrenal medulla in the middle produces epinephrine. Since epinephrine comes from the adrenal gland, in England they call it adrenaline. In England they call it adrenaline. So adrenaline and epinephrine are the same thing. This is the adrenal cortex. Okay? The adrenal cortex has three zones based upon the type of cells. Every hormone produced in the adrenal cortex is steroid. So that's why we call all hormones coming from the adrenal cortex the corticosteroids. The corticosteroids. The zona glomerulosa produces a hormone known as aldosterone. Aldosterone is what we call our sodium retaining hormone. Our sodium retaining hormone. Okay? See, aldosterone. Sodium retention. What aldosterone does is a hormone that retains sodium in the body and kicks out potassium. Retains sodium in the body and kicks out potassium. Now let's go over here and see if I can find aldosterone for you. Okay. Here's aldosterone. Okay. So aldosterone kicks out potassium but holds on to sodium. There are several things that can turn on these cells. One is your sodium level in your body. The other is your potassium level. But also these cells have receptors for angiotensin II. So when angiotensin II is produced, these cells here will start to secrete aldosterone, which will retain sodium, which then will retain water. Let's go back here. Now, if I retain sodium and water, what happens? The volume in the blood vessels go up, and therefore the blood pressure goes up. Okay, so that's one thing. All right, let's go a little further. We also said that it stimulates the production of ADH from the posterior pituitary. Okay, so here's your pituitary gland. Your pituitary gland has an anterior and a posterior. The posterior produces two hormones, oxytocin, which causes uterine contractions, and aldosterone and antidiuretic hormone. Antidiuretic hormone is also called vasopressin. Vasopressin, because ADH not only does antidiuresis, that means to hold back water, hold back you urinating, but it also can do some vasoconstriction. So here's ADH. Now, the most powerful controller of ADH is your osmoreceptors in the brain. Because again, osmotic pressure is what's being measured primarily. But also it can be stimulated to be secreted by angiotensin II. Now, angiotensin II can do it, not as much as the osmoreceptors can. Okay. Now we're going to talk about osmotic pressure in the body. I'm going to wait and do that probably more in the kidney area because that's a major thing. So we're going to talk about that more in the kidney area. But osmotic pressure is really what controls everything. And I'm going to make this bold statement. The body has no idea how much water you have on board. The body has no idea. There are no water meters in the body. Everything is indirectly being measured through osmotic pressure. The osmoreceptors are in the hypothalamus of the brain. The osmoreceptors are in the hypothalamus of the brain. So water amount in your body is being measured indirectly through the osmoreceptors. Now remember, the more solute, the more osmotic pressure. The more solute, the more osmotic pressure. So let's take this assumption. Let's say you had enough water in your body already. Let's say you started just digging in and eating a bunch of salt, just digging in. What would the salt do? That solute would increase the osmotic pressure. Now the osmoreceptors then would think, there's not enough water. When it is enough water, but you have too much salt. So what's going to happen? You're going to kick in ADH, you're going to kick in thirst, everything, to try to increase the water amount. Now, when you increase the water amount, which is over and above what you should have, then your blood pressure is going to increase. You see what I'm saying? So it's that indirect measurement of body fluid through osmotic pressure that can be a problem sometimes. All right. But angiotensin II can stimulate production of ADH. That production of ADH will go back here, can in fact hold on to more water. But remember also, ADH is also called vasopressin. So ADH can also lead to, even though this doesn't show it, increased systemic vasoconstriction because it also can do that. So we've talked about now the hormones involved. Now let's go back, okay? So ADH, okay? Now on the hormones, let's go back. We have another one called epinephrine. Epinephrine. So we're going to take this up in a moment. I'm going to end this one here, and then we're going to come and do some more on hormones. So we've gotten renin, aldosterone, and ADH. So we still need epinephrine and this. All right. We'll end this and start with that.